Hello everyone. In this video, in the third part of this series of designing welding positioner in SolidWorks, I have designed the enclosure and I have assembled added to the machine, and at the same time I have added this torch and designed this one. I mean uh, this welding this not welding, I can say the adjusting mechanism here. So it has one, two, three, four, five bars here, and it is connected to the chassis, and it has one, two, three, four adjusting knobs here. These knobs are, for example, this bar can rotate in left and right, and this one can rotate up and down, and this one similarly it can rotate up and down, and this one right and left to even this one itself can go down and up to make this torch to, to approach to the location of the welding. So here I have added two components as a sample. These are the samples that I have added and on the turntable, and this one I have added to make it clear that it is rotating, because you can see here, yeah, the when the turntable is rotating, these two components are rotating, and so since the torch is fixed here, the torching operation will be done here, and it will make the two components to be united after welding, you can see. So unfortunately SolidWorks doesn't have the system to show welding animation, but there is a, a welding uh, features here. You can see here this one. Where is this welding? The weld bead, yeah, here. So here, for example, weld path here, this one will be our path. So 5 millimeters the thickness of the weld. So let me make it okay. Okay, so you can see here that is the symbols, or the illustration of welding. So it means that it is welded. This is the two components are united to each other. So in the case of this enclosure, I have it is very simple. You can see here. Let me show you the pictures firstly. These are the final product, the final machine that I have designed and assembled the enclosure to the machine here. You can see here, even in the in the previous videos that I have uploaded in my YouTube channel, you can see here that this one, for example. Yeah, here in this video, this is the enclosure, the cover, but it's not final yet, because you see that the paint that we haven't painted. So let me show you something interesting here. Okay, so you can see that this is the proximity sensor is working here. So the large ring here, it was approached to the proximity sensor, and proximity sensor turn it on. You saw that. Let me see. Let me show you again. Okay, you can see that the proximity sensor is turned it on. It means that it sent a pulse to the PLC, and the PLC subsequently make this motor here to be to shut down. Okay, yeah, it was, you can see that it was circulating this turntable and it was stopped. Okay, So you can see here the enclosure is not final yet, and we haven't painted here. And even but here in this, for example, in this exhibition, in defense industry exhibition, it is done. And in this exhibition we took the machine to show to the participants in this expo, industrial, the defense industry expo. You can see here. Yeah. Okay. The designing cover is very simple. All of these components are flattened surface here, but there is there is another surface here. You can see here all of these surfaces are flattened. This one, and this one, and this one. But however, you can see that even this one and this one is flattened, but this one and I can say this one and this one, two, three, four, and this one. You can see here all of these components are not, or not all of these surfaces are not flat, and they are curved. So in reality, we don't fabricate curved surface. We firstly fabricate the flattened surface, and after that we band them to make them curved surface. But in SolidWorks, conversely, we firstly design this curved surface, and subsequently we change to the flatten mode. How we do that? It is very easy. You may already know that, but let me show you how we can do that here. So here, this one, we are going to make this one flatten. How we can do that? Let me insert this one. From insert, we can go to the surface and flatten. So selection, we select this surface here, and we have to select a vertex here. Okay, so you can see this vertex. Okay, and let me increase the accuracy here. Okay, so okay, and okay, you just see you see that this one is the flattened surface here. So how we can delete this one? Again, we have to go to the insert section and features and delete keep body. Okay, so here, not this one. Obviously we want to keep this one, delete, and we have to select this one, and it will be deleted. And so we are going to save it as a copy. And oh, okay, so we can to flatten, or to make that flatten surface here. Okay, so we can save that, and we can, right now it is very easy to close the original document here. Let me keep the original document. Okay, so it is very easy right now to manufacture or fabricate this flattened surface. We already here just the length of this surface has been changed. The other components, the other measurements are the same. Okay, so this one, no, we are not going to save. No, discard change in assembly. Yes. Okay, because we don't want to make the assembly destroyed here. Okay, so and I already showed you the welding bead here. Okay, so let's save the assembly here. So it takes time because I have done a lot of a lot of you can see a lot of mating here. So it takes a lot of time to save the document. So I have already shown you the motion study, how this turntable goes down and comes up. So but here, since the enclosure, I have added the enclosure and the torch, I'm going to show you again. So okay, 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 let's see that. Okay, you can see it goes down here. The cap is going down here. Okay, you can see that the turntable goes down here. And so since I have changed to the reciprocating mode, it will go up again. This one here. You see playback mode, reciprocating, normal, and loop. Okay, so the cap or the turntable is going to go up. Okay, so okay, what happened here? Let me make it 0 second here. Okay, okay, okay. Let's back to the model here. Okay, everything is perfect here. Let's do, let's save it again. Okay, okay, I just showed you the motion study, the first motion study of the previous video, part 2. After adding this enclosure and the torch and the adjusting mechanism here. Okay, so let me do another motion study because the first motion study was this about the second one. I mean the second motor, as I showed, the second motor drives the shaft, and the shaft drives the subsequently drives the this gear, the small gear, and the small gear drives the rotates the bigger one, the larger one, and the larger one is connected to the turntable, and it makes to the turntable to come down and go up. But the second motor here is via this shaft is connected to the turntable and makes turntable to move in revolutionary movement, to rotate. And so okay, the revolution should be like as this. Okay, so okay, I mean it will rotate, and since the torch is fixed, the component will be rotated and welding will be done smoothly. So let's do the second motion study here. Okay, create new motion study. Okay, so for the motor moves a component as if acted upon by a motor. It is a similar as a simulation of a motor. So instead of motor, we are obviously we are going to select this component, the shaft of the motor, as the component. So, and that is the rotation, and this time I'm going to make it a 6 rpm. because in 6 RPM means that 6 revolution per minute per 60 seconds. So that means that one revolution will be done in 10 seconds. So in reality, I have to mention that in reality it's not 6 RPM. This rotating, this turntable does not rotate in 6 p.m. because for welding process we need very smooth and very slow movement of turntable. Even the operator, without this machine, the operator, you see the operator make makes the welding process very smoothly and very slowly. And so I'm doing this. I'm giving this 6 RPM speed because I'm going to make this seconds animation seconds 10 seconds, and so because of that, I'm going to make that one revolution in 10 seconds because of the animation. For the sake of animation, I'm taking this RPM. So as I said, in reality, this is not the fact, but maybe I will decrease the speed after all. Okay, so let me do this. Okay, the next step is to specify the animation frames per second. Obviously, I'm going to increase that because we are going to make the animation smooth, the revolution here smooth. And finally, as I said, I have to select this amount of seconds. So let me increase that to 10 seconds here. Okay, so let's calculate that. Okay, it will make obviously it will take a lot of time. Okay, I will obviously delete the this section, this process, calculation process, and I'll make the 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 video short. Okay, so the process is going to be done. The calculating and creating of the animation process is going to be finished. So for 10 seconds. Okay, let's see how this one is working here. Okay, so let's play it. Yes, you can see here this one is working and comes here. So it should be one revolution. I don't know what happened here. Is that, yeah, it is, because yeah, it started from this point and it will go to that point. Yes, exactly. It is just one revolution per 10 seconds. But as I said, in reality, it shouldn't be, the speed shouldn't be so high. So let me decrease the speed of that. Even I think 0.25 would be okay. Let's test that again. Okay, yeah. Even this speed is a little higher than what is expected in welding process. I think if I change that one to, let me change that one to the lowest amount of speed here. Yeah, I mean, for the sake of reality, because it is just this the animation here. Let me select this one. Okay, let's do it again. Yes, exactly. in reality, the welding process is similar. The speed of welding operation is very close to this speed. So you can see that once this rotation table rotates, the component on it is rotating, and the torch here, you can see the torch here is close to the welding location, and it makes welding the two components here to make them united. So how this one is going to stop in one revolution, as I showed you here. Here, this proximity sensor here sees the approach to the bulged section of this ring there, this ring here, this ring here, and bulged section of this ring here, and it stops after one revolution here. So you can see here it is stop. So that's it. Okay, thank you so much for watching the videos. If you have any question, comment below. I will try to answer your question whatever you want. Thank you so much for watching the video. See you in the next videos.